Jordan, we've been having a great conversation about your background as an academic, then transferring over to becoming an entrepreneur. Tell me a little bit about what you were doing before and then what you're doing now.
Sure. So before I was a physics professor, I would study and contribute to the body of knowledge in quantum theory, quantum computing. Quantum decoherence was my big specialty. And so most of my time, by most, I mean pretty much all of my time, was spent doing research, publishing papers, and teaching. Now I'm running QRA, which is a software company. We design software that helps catch errors very early on in these big complicated products like medical devices, oil and energy, and try to catch errors before they're actually built into the final product. And I was co-founder and CEO of that. So on the surface, it's quite different.
Yeah, so on the surface, it's quite different. You went from being a professor, doing very theoretical work, to then now leading a group of people who are software developers. It's not even directly the field that you were a professor in. Um, what's I guess what contributed to that change? Like, what made you take that leap from an academic career where you had tenure, at a university and everything, to taking the plunge into entrepreneurship?
Well, I think it wasn't really any one particular thing. It was kind of a series of nudges that eventually ended up turning 90 degrees in a completely different direction. I would say the start of it came from a research contract that I had at the university, ostensibly about quantum computing. As I started, and it was an industrial research contract. And as I started, the program was successful. We were attracting more and more funding from our corporate sponsor. And as I got more into it, I started really trying to understand what was the underlying engineering problem they were trying to solve, not for which they thought this fundamental science and discoveries could solve. And even beyond that, what the business problem was. And that started opening up an entirely new world that, I previously had no access to it. Like we said earlier, I call myself an accidental entrepreneur. It came really about from trying to prove out the algorithms that I and my team developed at the university to see if they actually would work in the real world. And in order for us to actually do that, we had to build a product. To distribute the product, we had to build a company. And it sort of came from there. Once we started putting the first prototype in place and got it out there, we had a startup, but it was really kind of straddling both worlds. Once you saw the uptake in the market of this product, and we realized that we have something here, in order to do it properly, I would have to actually focus all my attention on the company. And I couldn't have two full-time jobs. I had to pick one, and I picked the company. That was about 6 years ago.
What was your favorite thing about being a professor, and what's your favorite thing about being an entrepreneur?
I had two favorite things about being a professor. One was I enjoyed teaching. Well, I should say I enjoyed lecturing. Teaching is lecturing plus a whole bunch of other stuff. So the lecturing was very cool. I also enjoyed the ability to do deep work, to sit and time and really think about it. And the reason why you can do the deep work is because as a tenured prof, you just don't have to do things that you don't want to do, right? You could just not do it and focus your time on that, right? So there was there was a little bit of administration, but no, now it's much worse than it was even like 5 or 6 years ago. But generally speaking, there was none of that, right? Oh, the financial administration, for example, you didn't have to do all that. Other people do it. That was really enjoyable. On the company side, what I like about that is you are really building something that is entirely new. You started something that did not exist before, and you're building it. You have people around you that can do it even better than you can. And you basically put people in place, and you're growing this machine or this organism, and you really are solving important problems that need to be solved, and you're seeing an impact. When we're dealing with customers, we see that the impact we're having. They're telling us what they like about it, what they don't like about it. So there is this kind of organic nature that has really no bound. Right? You can really go and you can actually make a dent in the world. Right?
And tell me a little bit more now about what your company does now. What's the problem that you're solving there?
Sure. So I think the way product complexity and systems complexity is getting to a point now that it pretty much exceeds human understanding, right? And the slope of the increase is getting more and more, right? So it's just going to surpass that. That means that the way we build things is going to be different. And the way we design things has to be different. And the way we verify things are going to be different. You kind of already see it on the manufacturing side with additive manufacturing, with adaptive algorithms and like generative design, right? Increasingly, what's going to happen, I think, is that people aren't going to build products anymore, right? And by products, I mean everything from cars to even oil rigs to pacemakers. People aren't going to build products anymore. People are going to build the systems that build the products. And so the issues that exist right now about building these complex products is that there's too many errors and testing takes too long. It's just so complicated that they can't even find all the errors early enough. They find them at the prototype stage. If you're doing purely software, you can, move fast and break things. If you're building an oil rig or a pacemaker, you do not want to move fast and break things, right? That's bad things can happen. So we spent some time. So we want to help people build better products that work the way they're intended to work. And we started off looking at the design phase. Now we're looking even earlier at the requirements phase. Most of the errors happen very, very early on when you're just defining the intent of the product you want to build and writing down the initial requirements, right? The requirements can be vague, they can be unclear, they can be incomplete. All these things start very early on in the project, and we want to build software tools that can actually analyze that, right? It could be in the natural text of the requirements you want, or what the business analyst writes, or what the systems engineer writes. It could even be the first models that you build. And that's kind of where we operate in order to help find and catch all these errors before they become big problems.
Okay. And specifically, what does your product do then?
So we will, the product we have in the market right now analyzes your corpus of requirements and technical specifications, and it will flag inconsistencies, ambiguities, contradictions, and incompleteness in them.
Is it like a form of natural language processing, or is there like an AI element to it? What's
the other is, the technology that's built upon is it's a whole slew of technology. So we're kind of technology agnostic. We're not really AI companies, although we use AI. We're not really an NLP company, although we use NLP. We want to solve this requirements problem, and we deploy whatever technology is available to us that we actually have to design or use other people's technology. So we do use a lot of NLP. We do use some machine learning, and we do that to both understand the text of what they're writing and also to conform to how the user wants to, or the organization wants to write requirements, right?
Okay.
We also do a lot of just like classic NLP and rules-based processing and heuristics that we put in to solve the actual problem.
All right. So last question for you. For somebody who might be a professor, happen to have a lot of professors in my network considering this, right? I think a lot of professors, particularly in the engineering fields, end up doing work where they see inventions, right? And they come up with something, they go, I can see this being a business. I can see this being a product. Some of them end up, kind of helping their students found a company and maybe serve as an advisor. But for the professors who are maybe considering making the leap and pursuing, making that drastic change from academia to entrepreneurship, what are maybe one or two pieces of advice that you would give them during that period of time when they're evaluating the option?
Number one, be courageous. And number two, take the leap. Not nearly enough professors actually do that. And not only that, not nearly enough universities provide the framework for which that can be done, right? And that is really, it's just really inertia, right? And it's just take the leap and actually try it. There's absolutely nothing wrong with having the students and the researchers, postdocs, start a company. That's fantastic. But we can do more. There's like so many problems in the world right now. There's so much latent potential trapped in universities that we have to actually unleash that into society. not just through students, but through the professors themselves. And if more professors did that, I don't mean like half the academia, even if like 10% do it, probably now what, 1%, not even 1% do it.
Mm-hmm.
Even if 10% of professors did that, it would completely revolutionize our society. It would make academia better and more responsive to the needs of society if they actually understood what it actually takes to go from invention to commercialization, to build a company, to deploy the product that people actually use. The invention is really the easy part, and as itself is very difficult to do.
Awesome. Do you think at some point you may go back to academia with everything you've learned in industry?
Never say never. I mean, it's not that I feel that academia was terrible and I never want to go back. I mean, it was good to provide a critical function, especially now. This may be part of a broader conversation, but universities historically have played a critically important role in our society, and they need to continue doing that. So they need to adapt to the society's needs. So yeah, sure, it's possible. It's possible I may go back, but we're still at the very early stages of this company, so there's still like many years to go here.
And it sounds like you're having a lot of fun with it. So maybe that's why it's hard to think about going to another lifestyle, given the great work that you guys are doing. Mm-hmm. Well, Jordan, thanks a lot for sharing this with me and with the folks here, and the best to you.
Not a problem. Yeah, thanks for doing this. I appreciate it. Lots of fun.